is the head of the distributed file system. Okay, we will see more than that. Oh, another thing is, once you write the data in the Hadoop file system, it's read-only. Okay, you cannot update the data. Also, it supports only sequential search, sequential reading, no random accessing. What is a random accessing? You can read the data using address, so you can read anything. Sequential is what is the example of the sequential reading? Magnetic tape. Magnetic tape is from starting to end. It's not almost impossible to read directly somewhere in the middle of the magnetic tape. You need to roll and back and forth, back and forth. No, that's wrong. This one, no random access, only sequential. And also, what did I say?
Right ones.
Oh, right ones. It's a read only. Why? 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 For speed. We don't want any overhead. If we allow update the data, much more complicated. We need to keep the memory space for update data, and if we allow the random accessing, we need to manage address. So that's the overhead. It will slow. It will be slow. Okay. So we don't have such a random accessing or the modifying the data. However, you may be updating the data using other components. So HBase, using HBase, so you can update the data. Okay, sometimes you can implement the random accessing using other components. However, basically the HBase does not support such a thing. Okay. So we will see how the files are. I already explained about that. So we will start. We have one node. Most of the system actually has two types of, most of the distributed system have the two types of server, two types of node. One is master, another one is slave. So in other words, coordinate and data, or something, the important job and the others, right? It's the same thing in the Hadoop system. Hadoop system has the master node, and all the others are data node, where we store the data. So master node is it has the it's called the naming node, and naming node is also called daemon program, daemon process. What is a daemon process in operating system? Daemon process. What is a daemon process? It's a
which runs at the background.
yes. For what? Service. It's the same as the service process in the Windows operating system. It's the background running. Even though you log out, still running. Like the web service. Web server is the daemon process. And FTP is the daemon process. You can see a lot of daemon process. It's the same thing. Naming node. The master node of the Hadoop system has the naming node daemon. It's a process. Okay? So, what is the main job of the naming node? It's a coordinate. Coordinate everything. All the other node. So all the other node is called data node. So this is a data node 1, data node 2, data node 3, data node 4. Which means in this node, in this computer, data node process is running as a daemon process. As a daemon process, data node is running. So this is the slave node or the data node. There's one more thing. Secondary naming node. Secondary naming node looks like the backup of the naming node, right? Because the naming node is the master node and this is slave, so much more important than other data node. Unfortunately, secondary naming node does not mean the backup of the secondary of the naming node. Instead, it's just a helper, helping the naming node to reduce the job, housekeeping job, something collecting data or the checking some information. So housekeeping job, keep communicating and update the naming node information, okay, to help. So what if naming node is down in your Hadoop system?
Second
No, it's not backup.
yes.
So your entire system will be down. So naming node in Hadoop is a single point of failure. The other, if a data node is down, it's okay. It's keep running, unless naming node is down. So naming node is a single point of failure. I don't know why it's named as the secondary. Secondary looks like the backup. So current version of the Hadoop support high availability, HA, which means you can have another backup naming node. So in case this one is down or failed, we'll take over another backup mirrored naming node. It's called HA is a general technology. It's not only for this one, high availability. So you can make the HA for your laptop or your workstation. So you need to install something program. So they keep communicating. If one of them is down or failed, then the other will take over. It's called the standby. First standby and take over the job service. So without any failure time, so you can keep serving for the service, like the web service, whatever. It's the same thing. So current, the Hadoop version, they support HA. This is just a housekeeping. Then what kind of information we are going to store in the naming node? All data node information. So you as a master of the this room or the instructor, I should know whether you are sleeping or not. Right? So they keep checking the hash. So that's called the heartbeat. So each node, data node, keeps sending the data. It's a heartbeat data. I'm alive, I'm alive, I'm alive. Every 3 seconds. If do not receive the heartbeat for a while, usually 10 minutes, naming node consider data node 1 is down. Okay? Then we'll ignore this one and keep sending. Actually, it will be go through the secondary node. Secondary node keep checking, and because naming node is the most important one, so should not be delayed. So actually, because of that, all information of the naming node will store at memory. So you need to have when you build a Hadoop system, big data system, you better have which one is more important? Memory, CPU, hard disk drive. Memory is the most critical. Okay, the bigger is the better, because they keep all the. That is one of the problem of the Hadoop. Hadoop use a lot of memory. Okay? So they put all the data in the memory. So to have So we have the secondary node. So what kind of information? So first we are going to start from the client. So this is a client node. Anything, they can be in the one machine. That may be possible technically, but we don't want to put everything in one, right? So in your practice, your virtual machine has the all this service daemon in one node, okay? That is called the pseudo cluster. It's a fake cluster, only for practice, okay? But in real implementation, for example, in the exercise lab 4 and 5, you will implement a real cluster by assigning this computer is a data node 1, data node 2, and the naming node and the secondary naming node. We use the 3 computer, right, to form a cluster. Then one of them will be data node 1, data node 2, 3, and one of them will be naming node. Just like that. Okay? Then we have client. Client also can be the same node, but don't recommend. So from other server, then I'd like to create the file. Create file means you have file, foo.txt file. This is a 1 terabyte size. For example, 500 megabyte size the file. It's in the local file system. Your ext, NTFS, whatever. Okay? Then using the command edu fs command, you can upload the data. Before you upload the data, first you need to connect to the naming node. Then inform. I'd like to create a file. Okay, then naming node know which server, which computer are available, right? So there should be, I'm going to remove this one. Basically 2 information, data node, what kind of node are available. And the file, first check. So then divide this file into divide by block size. So let's say we are going to use 128 megabytes. So which means we need 4 blocks. Okay. So it has the full 1 block, full 2 block, full 3 block, full 4 block. Like that. Then assign which node are available. At that time, naming node also know which one is close to each other. What does that mean close? What does that mean far? Computer can move around. In big data system, mostly we are using data center. This is the UB data center. And this is the Stanford data center. Each data center has the rack. What is a rack? It's a big box. Then we can slot the computer. We don't need monitor. We don't need the mouse. We don't need the keyboard for each and every node. Instead, only CPU, memory, and local hard disk drive. Sometimes it can be the SAN storage. It doesn't have to be in Hadoop. We don't get any benefit. So, rack. So each one is the blade style the computer. Okay. So this is the closest one. And this is the far. So we can consider distance 0, 2, 4, 8, something like that. Then naming node know where each node is located, then calculate. So data node 1, data node 2, data node 3. So first block FLBLK is data node 1, data node 2, data node 3. Then return. So you can use data node 1, data node 2, data node 3 for first block. Then we don't have to go through the naming node this time. Directly contact the data node and copy the first block. First block is FLBRK. How many copies of each block? 3. Then this client knows DN1, DN2, DN3. There's in order. Okay. Then directly communicate. And 3. One data node 1 is receiving the data and write and sending to the next one. And also next one. Okay. Then once this is done, return, return, return. Then finally inform to the naming node is done. Then we can have the 3 copies of this one. Same thing for 2. Actually, there is a detailed algorithm to assign the node, but basically it's from the closest one. And the next is the 2 copies of them, but you don't have to worry about the security. But you should understand how they are copying the 3 copies of them. Then we can have this is 2. This client contact the naming node 2. Then 2. Like this way. Okay. Then there is a meaning of this one. Also, another thing is, after this one is in the data node 1, data node 2, data node 3. 2 basic information. Per node, what kind of blocks are located. And per block, where is the copy of them. This is the writing. Reading is quite similar. When you read the data from the client, request first to the naming node, because naming node know everything. Then request the foo.txt. When you take a look at the foo.txt, there are 4 blocks. The first block is in the data node 1, data node 2, data node 3. And data node 1 is located in the here IP address. And, oh, by the way, all communication are based on what? HTTP. What is the HTTP? You probably heard about HTTP. It's a hypertext transfer protocol used for web. Okay? This header is based on the HTTP protocol. Yes.
Why they are again dividing? It's already divided to 4 blocks, 4 files.
Oh yes.
It is divided into 4 files. And again,
No, not 4 files. It's 1 file, but automatically divide by the size of the block.
Yeah, size of the block. So according to that, 128 megabytes is there. So 4 files they are divided.
Yes, so 112 byte, 128, 128, then remainder.
Yeah. Again, why again they are dividing here in the data node?
This one?
Data node.
In data node. Yes, you copy the first block only in the data node.
That's 128, right?
That's what?
It's of size 128, right?
It's a 120. All data in this, not always 120, but maximum 120. What about the last one? What is the remainder? So, can you calculate? Anyone calculate? What's the remainder? 1? Whatever, 32, let's say. Okay? You don't have the header is not the stupid to create the entire block. Instead, only 32 blocks for the last.
No, what I mean is like first data node it can assign 128.
Yes.
Second data node 128.
Yeah, it's a copy.
Oh.
Because as I said, we need 3 copies of them. Okay, for what? Just in case this is down. It's not available, then this one will be used. Even though this one is down, this one will be used.
Like that, how many copies will it?
The 3, minimum 3. You can set up minimum the copies of the data. So if you want 10 copies, if you have the enough size. But mostly 3 is enough because it's not frequently happen 2 of the data node, 3 of them are same time down. Only in case entire data center is down. Because of that, when they assign 1, 2, 3 copies along the data center. First, find the closest one. Then second, the different, a different data center. Even though this one is down, this one will be used. Any other question? Yes.
How about for 3?
2, 3. This one.
Yeah.
So this is the third block. Yeah, third block will be assigned to this one, the 3 ELK, 3 BLK. So it can be started from here. Then copy and copy.
Always 3.
Yes.
block?
So because
Okay,
we set up the 3 copies of the same data.
Always 3.
Always 3 if you set up 3. If you want 4, then it will be 4 copies. If you set up the 5, it will be 5. But most of it, as far as I know, most of the system use 3 copies. Okay? Most of the system use the 3 copies. Which means if you have total 1 petabyte size data, you should have at least 3 petabyte storage. You need to consider that one. And plus overhead. Okay? So when you read the data, yes.
Does that mean that we have at least 3 data nodes in the architecture?
No. So as I said, I have a 1 machine. Okay? Then you can create the 1 data node. Then you can set up the 1 copy. Okay? But that's not, you cannot, just that's for practice. Okay? Okay, then even though you create the 1 data node, but you can create the 3 copies in the same.
Oh, yeah, I understand.
Okay, then when you read the data, so this is a writing. When you read the data, we need a little bit more. I think I'd better explain that later. First, read the data, request the foo.txt. Then check foo.txt has 1, 2, 3, 4 block. So first block starts from here, dn1, dn2, dn3. Do we need to access all 3 at the same time? No, we don't have to. Just the closest one. So dn1 will be the retrieve. And also from the block 2, second block, we need to access the second, third, fourth? No, just one of them. Okay, something like that. Then directly contact from the client to the node and return the data. Once you finish that, during the MapReduce programming, there are 2 more the process. One is the job tracker. It's a kind of master of the program. It's a coordinator of your job. Okay? So, because we don't discuss yet what is a MapReduce programming, but MapReduce programming is kind of parallel programming. So this is a coordinator of your job application. Then each one has a task tracker. So, for example, this task tracker will access first block. This task tracker will access second block. This task tracker access third block. This task tracker will access last block. It has a locality. What is a task tracker? It's a program. It's a daemon program running on this system. So we have naming node, data node, secondary naming node, job tracker, and task tracker. There are 5 basic services, basic process running on this Hadoop program. Okay. Any question? I know, first that's not easy, but eventually when you have a lot of time to set up the real cluster during the administrator, some of team may be failed. Don't worry, okay? But while you are setting up, you will learn the most of the such naming the processes and daemon programs. Yes.
Sir, the question is just curious. When we how to create the copies of the first block, so what is that size? Is same size?
Same size as what?
Yeah, it is 128. So is the
Yes.
copy is the same size like 128?
Yes, so exactly same. It's the same copy, same copy, same copy.
So when the size is like Teradata, so
So that's what I'm saying. If you have the 1 terabyte, 1 petabyte, for example, 1 petabyte, the data file, it will be 3 times of that. You should have at least 3 times of your data. Okay? Because of that. Why? Otherwise, if you have only 1 copy, it's not fault tolerant. You will lose your application. You will lose your data. But nowadays, good news is storage is not that expensive. Okay? Because of that, I think they set up 3 copies as a default. Yes?
I didn't get the job tracker, test tracker. Does that mean like job trackers coordinate with test trackers?
Yes.
Or the software?
Job tracker coordinate the
Okay.
task. It's a program.
Okay.
Map reduce part. When you
Software level.
learn the application. Okay?
So
But that's a slight huge change actually in the Hadoop version 2. But I will introduce that is called Yarn. Yet another resource manager. What? Resource manager?
Yarn
YARN.
by
The resource. What is that? Anyway, I will show you later. So that is the resource manager. So resource manager in the Yarn, the Hadoop 2 is they separate the job or the job tracker and task tracker. Task tracker for each application. I will introduce. But in our practice, we will use the Hadoop 1, the old version. But still, the Hadoop 1 previous version are used a lot in the market. So pretty much when you learn the first time, the Hadoop, the old version, map reduced version 1 is enough to understand. Okay? I will show you
Can we
after
consider-
break. Yes.
Can we consider that as a part of MapReduce? I mean, the task tracker and trigger and job tracker? The tracker, sorry.
Yeah.
Are they part of MapReduce or like the
Oh, no,
MapReduce
this
different
is
thing?
the process, service. When you start up the Hadoop, they are running. Okay? Then their job is, data node is to manage the data. Okay? The task tracker is to manage the instance, the part of job of your MapReduce program. When you submit from the here, application MapReduce programming, they are actually doing read the block, then the calculate something, or the mapping, or reducing. So it's a task tracker. Okay? But it's a change it in the Yarn, the version 2, but I will show you the comparison. Yes?
If the file is too small, do we need to divide it into
Small copy will be copied. Okay? For example, I have the 1 megabyte file. Actually, they do not use the 128 megabyte entire the block, instead the 1 megabyte. Yes,
How the test tracker synchronize the task?
that's the job of the they are communicating each other using HTTPD protocol. Also, they are running on top of Java virtual machine. So their basic, also the architecture is a Java virtual machine. Okay? So you can use the benefit of the Java virtual machine for communication each other, like the RMI. So you can use RMI. So for example, when the task tracker is running on this one, here count is 1,000. Here count is 2,000. You wanna know the count of this one from here? At that time, you can use the Java RMI for you can assign the local variable, global variable, something variable. to the RMI, then they can share. That is the benefit of using RMI. I'm not expertise on Java, but I know such a basic architecture. If you do not know much about the Java, it's a good time to know. Really. So Java, Python are very, very important in the data analytics. Okay. So yes.
Is this they provide Hadoop as a web service
Uh,
or any?
what is a web service?
I mean like through the internet we can access and we can analyze our.
So actually, this is if your entire network policy is open to public, you should be able to access the data.
So that's
But
why
yeah, in the local, probably not. So in the local, to connect to communicate to each other, you can use actually HTTP. The semicolon slash to give the IP address and slash something the shell script, then you can actually get the information.
then it's like it's related to a single company. I mean like inside the company they can use this.
Oh yes.
Not like it's not like for public.
No, it's not for public. So because I understand what you are asking, because the web service is usually to get the request from out of the network, okay, through the as long as it's routed through the IP address, yes. But this is only there is no you can directly use the IP address or the local DNS, okay, not public network, okay. So you will see later when you set up the Hadoop cluster. As long as the computer is connected to the local area network on the same switch or same router, then you can actually communicate each other. But that doesn't mean they can be retrieved from the out of UV network. Probably your firewall block. Any other question? So we will have the short 10-minute break. So what time is it?